I was planning to do this poll while I was about to talk about BigQuery, but in the audience, if you could just let us know if you are familiar with BigQuery at all. There is a possibility you never had interactions. If you can let me know you're not aware of BigQuery, you don't know what BigQuery is, or have never had any experience with BigQuery at all before, hands-on, I would say. Anybody? Hands-on experience. All right. For those who don't have hands-on experience, we are having a workshop tomorrow at 11:15, I believe, in Jasmine Room C. Feel free to stop by and we will take you through that. If you're familiar, I was expecting more people to be new to BigQuery, but awesome. All right. I think 2 minutes, we can start. Good morning again. Good morning, everyone. And welcome to our session, Unleash the Power of dbt on Google Cloud, where we discuss our partnership with dbt, as well as I'll give you a primer on BigQuery and what is new, as well as like a few key innovations. We have been working very closely with dbt and deep dive into BigQuery DataFrames and the dbt integration, as well as we will have a few demos and you will have options to, at the end we will have time for questions too. To that end, I'm Jobin George. I lead the data analytics partner engineering function at Google Cloud. What that means is I get to work with ISVs like dbt and create joint solutions on Google Cloud and co-innovate with them so customers like yourself could benefit from that solution. I've been with Google for almost 4 years, and prior to that in a very similar capacity at AWS, Hortonworks, Netgear, and so on. I'm also joined with my co-speaker, Sandeep. Sandeep will help you understand what dbt, BigFrame, or BigQuery DataFrames integration with dbt is. Even today, organizations struggle with siloed approach, meaning which different personas working on different, same copy of the data, but working on different tools of their choice. Even there are teams who are just using Excel and trying to make sure that, hey, I will work my way, but at the end of the day, that will create challenges as a holistic organization to get value you would need when it comes to business, utilizing that insight from the data and getting any sort of benefit from the data operations you have. To avoid that siloed approach where your data engineers working on their own copy of the data, data analysts working on their own copy, as well as like data scientists doing their modeling and predictions on their own copy of the data, they're not going to trust each other's insights, and that will land into bigger troubles. And at the end of the day, organization may not benefit from any of the insights you have. To solve that, you would need a platform which can handle the scale, as well as like be an architecture which will help you to work with multiple tools on the same copy of the data, so that in a transparent way, you can also have a transformative and modeling layer sitting on top of it, where these teams can collaborate and ensure that they have this trust when it comes to understanding how the data arrived into the location where they are and how other teams are working on the data, and then go from there. This is where Google Cloud, particularly BigQuery and dbt, comes into the picture, where BigQuery provides a capability within the framework, having an opportunity for you to have an open platform where you will have a collaborative layer with dbt platform, having you to have that trust built in within the team. Collaboratively, you will be able to make data journey as smooth as possible, and then derive insights which will benefit the business teams and so on. That is why we are very excited with the partnership we have with dbt, in a way that it enables our customers to have an open, flexible, as well as powerful data ecosystem on Google Cloud. That's why we have been working very closely with the dbt team to bring on dbt platform onto Google Cloud so that in a way you will be able to co-locate your transformation layer where exactly the data resides, which is in BigQuery, right? So that increases the performance as well as reduces the latency you probably would experience otherwise. Personally, myself, I have been working, and my team have been working really closely for that well-architecture, implementation of dbt platform on Google Cloud for quite some time, and we rolled that out with a lot of features which are still coming and trickling in as we speak. Also, we launched dbt on Marketplace, which makes it very easy for our customers to procure, as well as simple billing and help you offset your commits you may have with Google Cloud. Along with that, I was privileged to work with dbt to get them Google Cloud Ready BigQuery validated. What that simply means is it's an accreditation or a certification for the dbt adapter for BigQuery, ensuring that they are using the latest and greatest features, APIs, and capabilities within BigQuery under their under the hood for their plugin. And we have a very rigorous testing and validation process in place, which makes sure that this capability is seamless when customers try to use both these solutions together for their production workloads. Like I said, I want to also give you a primer on BigQuery, what is the latest capability, and so on. BigQuery is our flagship data and AI platform, which enables you as a customer to utilize the capabilities within, which are not just data related, but AI capabilities too, to help you query the data, massive amount of data within a few seconds. Right? It is completely serverless, irrespective of where the data resides, in what format it resides, and what engine of choice you would want to use to analyze this data. You will be able to get that with BigQuery, without worrying to manage any infrastructure at all. That's the beauty of serverless engine. You will not have to have an administrative team to take care of any of operational functions you would typically need from other warehouse solutions. And of course, like I said, it supports any sort of data. The data could be sitting in Amazon's S3 or Azure storage, Iceberg format, Hoodie. It doesn't matter. It gives you the single pane of glass or a unified access layer to get into different types and formats of the data as you need it, and given the benefit of having Google Cloud's infrastructure to support it. Again, like I said, multiple engines on a single copy of the data, which means using a single user interface, you will be able to utilize any of these engines like Federation with Spanner or BigQuery Dremel engine for your SQL queries, as well as open source engine like Spark or Flink or Kafka. Depending upon your use case, you will be able to utilize that. And what that means, think of BigQuery as a perfect toolbox with perfect tools for each of your job. So depending upon what use cases you have, you will be able to take advantage of the capabilities within BigQuery. And it also supports integration with Vertex AI, as well as native capabilities which are AI related, like Canvas, as well as conversation analytics and so on, which you can make use for a variety of AI use cases as well. And as mentioned in the slide, we have more than 600,000 customers using BigQuery Studio, as well as we have seen 500% increase when it comes to serverless Spark usage. One other advancement we have is Big Lake Iceberg tables for BigQuery, which that means is you will be able to build an open standard data lake on Google Cloud with the help of Apache Iceberg tables in BigQuery. It simply means you will be able to use the engine of your choice, third-party, open source, etc., on the data residing in in your account, which is in your GCS bucket, completely managed by BigQuery. So you will have the flexibility of managing it, and to sweeten it, dbt. The latest version of dbt supports Apache Iceberg tables in BigQuery, so that you, as a customer, will be able to utilize a DBT platform to create and manage Iceberg tables in BigQuery. And of course, like then it opens up their opportunity to utilize different variety of engines to talk and communicate and manage this particular data under the hood. I also would want to touch on one of the security enhancement we have, PSC or Private Service Connect, which helps you to establish private and secure connection from a multi-tenant provider like DBT when you're trying to access your services inside your VPC on Google Cloud. You will be able to utilize Private Service Connect, which is supported in preview, and establish connectivity in a way that it doesn't go through the public internet, but instead a private channel for you to establish that. And you can utilize that with the latest feature provided by DBT Cloud. Another one we have is BigQuery Workload Identity Federation. If you are tired of utilizing service account, which are in JSON format and you have to upload into multiple location, your security teams would panic by knowing that, okay, there is a long-lived key somewhere out there. You can integrate your IDP with this, or you can simply use other options like OAuth support in DBT. This is a third one for enterprise customers who will benefit. And as of now, Azure Active Directory is supported, and you'll be able to make use of that too. Lastly, DBT Python model for BigQuery is supported. I don't want to talk a lot about it. Sandeep will deep dive into this feature, but this gives you the ability to interact with interact from DBT on creating Python models and running that in BigQuery. I also want to showcase how well adopted our joint solution is. More than 5,000 customers jointly use DBT and BigQuery together for their transformation modeling as well as like testing work. That shows the trust the customers have put in. I'm not talking about users, we are talking about logos of customers. And of course, like Duolingo, Avida Health, Dish, Build Rewards, and Rocket Money are some of those marquee customers who use BigQuery and DBT together. I will also show a quick demo. Since we are in a little bit crunch of time, I thought I would record the video and show it to you, and I will be able to walk you through that while the demo is playing. So, if you are not familiar with BigQuery, like I said, since DBT launch, DBT is Google Cloud Ready BigQuery validated, you can sign up for a trial through BigQuery's console and create an account from DBT account into DBT, and then you will be able to, once you have the account ready, you will be able to set up an account or connect your DBT account with BigQuery by utilizing any of these capabilities we have. It's better to use the BigQuery connector rather than the legacy, which supports workload identity federation also. For this particular demo, I have set up a connection already, which is talking to my data set, BigQuery data set sitting in my account. I also have a model which I created based off of a data set I have, and that is creating a table with a particular set of fields I am using. Imagine I'm a data engineer, and my business team is relying on that data set to create a dashboard. The business team gave me a new update, or they said, like, I need these changes to this. I'm just faking it by commenting out a particular field here. But imagine they gave me this, I updated that without realizing I made a mistake. And then it is very easy for me to go ahead and save that as a new branch, and then definitely to commit it and then run it, run the model. And when I'm running it, what is happening is like that particular field I had, it is actually gone. And when that is gone, it will create issues, and my dashboard, which I have built for my business user, is broken, and then they are panicking now. When they are panicking, they yell at me, and now I have to go and fix it, right? So to go and fix it, I probably will have to go back to there, the DBT console under the studio. I will switch back to the main branch, which I never committed to for the testing purposes. I just used that branch before. After validating, I thought I will do it, saved my job. I will rerun the model after pulling it back. It persists the data back into BigQuery. With that, the table will have that particular field I commented out back, and then it's easy that my business is continuing as usual, and I'll figure out, get some expert help to fix that code. This is a simple way of showing how powerful dbt and BigQuery solution is. There is a lot more to talk about it, but in interest of time, I'll have to stop here. If you have any questions, we can take that at the end, or you can come to the workshop we have. With this, let me hand it over to Sandeep. Sandeep, please. Thank you.
All right. Thank you, Jobin. Can you guys hear me okay? All right. Hello, everyone. I am Sandeep Karmarkar, a product lead with BigQuery. I lead the areas around advanced analytics and agentic capabilities in BigQuery. But today, what I'm going to be talking about is a new feature that we have added to our BigQuery plugin. With that feature, our customers can now support their Python models using BigQuery DataFrames. To explain what this is, let me step back and explain what BigQuery DataFrames is and what problem does it solve. So let's jump into it. Python is a very common language in the world of advanced data science and data analytics. Libraries like pandas and scikit-learns are very commonly used. And this experience works really, really well as long as your data fits in within certain size or your compute requirements are to a certain limit. Think of it this way, as long as it fits within one notebook execution system. But as soon as you relax one or both of those two dimensions, maybe because you have larger data to process, maybe you have higher compute needs, or maybe you have both, that's when this experience starts breaking down and you start getting into the red zone. This is where we see most of the data practitioners switch out of this single notebook experience into a more distributed system. Maybe they're adopting Spark, maybe something else. And across all these distributed systems, they face three key challenges. First, now you are betting on a new infrastructure, which means you have higher costs of the infrastructure, you have higher cost of managing the infrastructure. Second, you were pandas experts before, but that doesn't translate to this infrastructure anymore. So you have to upskill yourself. You have to learn PySpark. You have to learn some other technologies. And to get the performance that you need, you have to now know the 1,000 tunables that you need to tune to squeeze the performance out of these systems. And what you are really trying to do is, hey, I have this pandas job. I need to make it work on large amount of data. But you have to go through all of this to make it work. This is the problem we saw a lot of BigQuery professionals facing in their Python experience and decided to solve it. And that's where we launched an open source library managed by Google called BigQuery DataFrames. I'm just going to call it BigFrames for shorts. BigFrames is a transpiler of sorts. It offers pandas and scikit APIs. So to a user, it looks like they're using pandas and scikit. But behind the scenes, it is transpiling that into SQL. It is building the SQL tree on the client side. And then lazily, optimally, it is pushing it down to SQL. So there are two things that are happening here. One, the compute is coming from BigQuery. So now you have the entire distributed computing power of BigQuery in the pandas interfaces that you are used to. Second, data never gets copied out of BigQuery. A data frame in BigFrames is actually a virtual representation of a permanent or a temporary table on BigQuery. So now you can process terabytes of data with BigQuery compute power without switching out of pandas in the notebook that you were used to. That's the power of BigFrames. And we not only offer you the pandas APIs, but we also offer the BigQuery's native machine learning capabilities, the serverless machine learning capabilities through scikit APIs. We have been extending these APIs to support some of the native capabilities that we are adding into BigQuery. Think of things like vector search with embeddings. Think of things like continuous queries, or things like our new Gemini integrations within BigQuery. All of those are coming into a Python data frame library with BigFrames. And if you want to bring your own libraries, your own functions, you can also give that to us, and we'll automatically deploy those as server-side functions and execute this seamlessly within your Python code. So this is what BigFrames is. The story here really is going from a gigabytes of data to terabytes of data with a simple switch of a library. This product has been generally available for more than a year now, And we have seen tremendous adoption. We have customers processing hundreds of petabytes of data, again, within a single notebook, and doing things like data wrangling, data processing, feature engineering, feature manipulation, all without switching out of pandas or scikit or Python that they are used to. So that's the story of BigFrames. Now, let's tie it back to dbt, right? Within dbt, you guys are expert. There are two types of models. There are SQL models, and there are Python models. For most of the cases, we completely understand people use SQL models, put them together, chain them together, get their work done. But then there are times when you need to bring in some advanced processing capabilities. You need to bring in those Python libraries. Or maybe it's not easy to express some of that logic in SQL. Or maybe you're a data scientist who really love pandas and Python. And dbt recognized this need and introduced Python models as a first-class models within dbt about, I think, 3 years back. So this is a first-class support within dbt. You can do it in dbt. However, when it comes to BigQuery, the only way you could have used Python models with BigQuery before this was choosing PySpark, which brings back the memories of Spark again. And that's what we have changed now with the launch of BigFrame support in dbt Python models. As you can see here, all you simply have to do is you write your Python code, and you say submission method is equal to BigFrames. And then you leave the infrastructure on us. You do not have to manage any new infrastructure, learn any new language. We take your Python code, we execute it for you. It's a BigFrames code, so it gets getting pushed down as SQL. So most of the processing is going to happen on BigQuery. So within dbt, again, you can process terabytes of data easily with pandas-like interfaces. Right? It also supports a lot of advanced capabilities. If you want to bring in your own custom packages, you could do that. If you want to chain it with other SQL models, you could do that. If you want to do incremental materialization, you could do that. All of these capabilities are now generally available in dbt Cloud as well as dbt Core as of today. Hopefully, Fusion and other versions in future. For the curious minds here, right? I know a lot of folks here are developers. I also wanted to point out one nuance, right? dbt does not give us a Python runtime to execute our Python code. And it expects data warehouses to provide this Python runtime, and this is a Python model. So how do we do that? So what our plugin does behind the scenes is we take your Python code, we put some wrapper around it, and automatically push it down as BigQuery notebook. So there's a BigQuery notebook that executes on BigQuery side, which executes a BigFrames code, which gets again pushed down to BigQuery. So a large amount of your processing is happening still on BigQuery, but you will also see BigQuery Studio notebook execution showing up in your project. All of this happens with your permissions, whether it is your service account, OAuth, or WEF, all of that is supported. So this experience is completely secure. BigQuery also has built-in lineage. So if this gets transformed within BigQuery, the lineage is auto-captured. You can go to BigQuery's native UI and see lineage showing across. So this is a very secure, governed experience without need to learn any infrastructure of sorts. Let me see, how much time do I have? I have about 5 minutes. So I really like live demos, but I can't do it today. So I'm also going to walk through a video. The video here is we are trying to build a Python model within dbt. And the idea is to predict ozone levels, based on some air quality data, public data sets that we have within BigQuery. Don't do that. This is not going to work in real life. This is a toy model. But what we have done here is we have created 2 Python models to achieve that, and just to show how it goes. Right? So this is available as a blog if you want to get into the details. You can search for linear regressions with dbt BigFrames, and you'll also find these details. So here is a public table. There's a data set called air quality, tons of tables recording lots of weather data, whether it is certain weather elements, whether it is temperature, wind, and whatnot. Within dbt, now I have created 2 Python models. Now in this video, I struggle a little bit to get to the lineage. As I get to the lineage, you will see there are 2 Python models that are built. One that prepares table, and then I carry out a prediction. In the prepare table model, you will see I have a dbt config that says submission method is BigFrames. And then I go through and load different data sets. This is my public data set. I'm going through different columns. And then I'm going through different tables. Each of these tables stores features for my models, right? So these features is what I'm going to slowly load into my tables. Now this is Python, so I can do an easily a for loop. So within a for loop, I'm going into and loading each of these using a read GBQ interface, sorting values, dropping duplicates, setting index, rename, very easy in Python, just chain your operations and build these tables. So these were the easier tables. Now there are some other tables which have feature data as multiple columns within the same table. I'm going through that and building that as well. As I go through this, you will see I'm doing simple Python operations, putting this all together in a data frames called params data frames. And at the end of the day, I'm going to put them all together and concatenate into a single data frame. That will be my feature table. So this is where I'm concatenating, and I'm saying, OK, return this concatenated data frame as a table. This will get materialized automatically within BigQuery. This materialized table gets utilized in my next step, which is my reference. And I say, now I want to train it. So there's a train data set, there's a test data set, and there's a prediction data set. So I'm setting training and prediction here. Let me speed it up a little bit. I'm not used to watching videos at 1x anymore. Yeah. All right. So this is my prediction data set. I'm dropping the ozone column from that. And now this is an interesting one. Linear regression is natively supported. So you did a fit, score, and predict. 3 simple statements. You did not have to reserve any infrastructure to do model predictions here. This is power of BigQuery ML. I like the model. I can even save the model back to BigQuery, right? And then the prediction table comes back. So these are the things. I prepared a table. This is where I can see the preview of the table. These are my features. So you can see the feature columns are now created all the way to the wind direction. And then I'll go back to prediction and see this is what my prediction looks like. The first column is O3. So these are the steps within my dbt model that are getting materialized as BigQuery table. And the last model I saved, this model is available here as well. It's a linear regression type model I saved. It knows where it was created. These are the features I used. This was a label column. If I had done evaluation, you can see model evaluation things here. You can connect to Vertex registry, and you can do predictions as well. This is a part where I can also show you this got created into a notebook. And if you ever want to go and check the notebook details that are also available, it's completely transparent. So you'll see that this is the code now got converted into a notebook. A wrapper got put around it, the same code that goes through with it. And at the end of the day, this is going to do the same thing, saving the model, returning the data frame. And you'll see each of these are getting executed as BigQuery jobs. So this is the BigFrames part of it. It's getting converted into BigQuery and executing it down. So that's what we did. We built 2 models to predict air quality, ozone levels in air quality using dbt BigFrames. You can learn more about this in our documentation, in our quick start. We also, talking about data science, we also have a new ebook that will talk about all the different BigQuery capabilities around data science, or also our native Spark capabilities around data science. So definitely check it out. For those who are new to BigQuery, try it for free. You will be surprised how easy it is to get started and use it. And lastly, we do have a hands-on session tomorrow, so join us. We'll go through a lot of advanced analytical capabilities on BigQuery. So hope to see you there. I don't know if you have time for questions, but I'm happy to stay back and take questions. Joe? Go ahead.
Can you talk a little bit about query performance of native BigQuery stored tables, where it's the executions within terminal vis-a-vis like something like Iceberg, where all of the data lives in Parquet and PCS, and then you're executing it against BigQuery's engine or something?
Yeah, it's a good question. So we do have 2 versions of Iceberg tables that are called BigQuery Manage Iceberg tables or external Iceberg tables. Within BigQuery Manage Iceberg table, the performance comes very close because the execution is still happening within Dremel, right? Interestingly, the BigQuery storage is not actually different internally than what GCS storage is. So internally, it looks very similar to us. We do have additional performance improvements, things like caching for our managed offering, and there's more coming. Metadata cache. The most critical thing around Iceberg is metadata caching because the metadata looks different. So that's something that we are actively working on it and rolling out. So it will be very close for managed Iceberg tables.
Obviously, no command, but like any idea when like the REST interface for Iceberg is going to be GA?
Well, yeah, I
think it is GA.
I thought it was GA, but if it is not, I'll check back.
GA right now on the website. That's why I was
Oh, I see. It'll be GA soon then. It is very close. Yeah.
Q1, Q4, or
I would say Q4. Yeah. But I'll check back. Yeah.
So for the Python models,
Yeah.
when we explored it, it was going to run in dataproc, and you would have dataproc cost if you were running Python models like maybe like 6 months ago.
Yeah.
That's not the case anymore, and we'll just have the slot cost or whatever
Yes.
quota we have.
That's exactly right. So it'll use your BigQuery project, BigQuery slots, and it'll just run with that.
And this is available as of today. Like,
It is available as of today, generally available now. Try it out.
one more question.
Yeah.
Is there anything on the data, like when we learn about BigQuery, we also learn about data form,
Okay.
which is also like exists right there next to DBT, right, for us.
Right.
So is that something that you guys are working on, or is that will eventually go away, or to get more features?
No, Dataform is definitely not going away, right? So for those who are mainly focused on the BigQuery universe, right, Dataform is a first-class offering, and that will stay more and more relevant. So it's getting more features. So for example, if you have seen our AI-based data preparation tool, that is based off of Dataform. It creates that SQL X files automatically. It does data wrangling automatically. You have a visual editor for that. So those capabilities within Dataform will keep on building, but we have a strong partnership with DBT as well here, because we understand people like choices. They have other data warehouses as well, so that's not going away either.
Yeah,
We have a dual strategy.
Just to add on to that, like if you look at the capabilities which DBT provides, the features and the maturity of the features you have within DBT, it's not comparable with what we have in Terraform. And only you have BigQuery or native Google services integration within Terraform. While DBT, we have even customers using Databricks as well as Snowflake with DBT on Google Cloud. So you will not be able to get that interoperability with our services. But if you are a customer who is only looking for a basic set of features versus like no sophistication needed at all ever, Terraform would be a choice. But if you need enterprise level features and mature features, you will have to look at DBT. And of course, like the community behind DBT is not a joke compared with what we have for Terraform. So the feature and everything will be like only catered towards BigQuery customers who are asking for a certain set of features just for our integration versus that. Is it clear? Yeah, thank you.
Go for it.
Is it purely the ease of operation for like data science team in terms of adopting DataFrames, or is there something much importance game between running things on Datapop versus DataFrames?
I think the performance, your mileage could vary because it really depends upon what your workload is, how you have tuned your Spark cluster. So we have seen both ways, but what we can see, like if you run the same query on BigQuery versus run through BigFrames, we are within 5% of BigQuery performance. So you will get the BigQuery performance. Now really, what you are really comparing is BigQuery versus Spark. And again, that performance, it really depends upon your workload. There are some where this went, some where this went. So.
And then the second one is probably more for yourself. So you had shown sort of a demo where you're going through DBT and BigQuery and going to a dashboard. I was curious on your experience working with other groups on the lookML layer that sort of is in between getting to the dashboards on.
No, the dashboard which I was using is Looker Studio, not Looker.
So it's not using the lookML.
No, not in this particular demo. But Looker Studio is more convenient. Like I said, for demo purposes, it's okay to use Looker Studio. It's just when you have like sophisticated dashboarding, you would have to look at Looker, right? So yeah, in the demo, it was just Looker Studio. Sure.
Awesome.
Hi.
Sorry, I missed that part for Dataframes. What did you say? Is it already compatible to DBT Spark package, or it will be in the future?
Yeah, Dataproc, you can already use Dataproc, not the serverless Dataproc or the cluster Dataproc. Both are available if you want to use Dataproc through DBT.
Okay.
Yeah, that's what your preference is. It's available.
So we deploy a lot of tables in BigQuery through DBT.
Okay.
We also have a slice where DBT is not involved, especially like getting data from outside,
Sure.
so like Coalesce or something.
Yeah.
So what, like, and this is like unrelated to DBT, but we find like sometimes lacking in terms of how we deploy DDL to our like projects, and mostly it's like custom built GitHub action, which like it's kind of like we find issues sometimes when we are deploying. So it's more like we just provide the whole DDL and then basically we have kind of create or replace or something like that. Versus models deployed through DBT kind of handle that very good.
On your behalf, yeah.
So curious if there is, I don't know if we just don't know about it. There is a way where it's more some kind of native integration where we can deploy changes to it, like adding a column or something without saying alter table add column, where just add column to the DDL and it identifies like okay there is a column change and takes care of it. So something like what we did in DBT. So like for tables which are not deployed by DBT. I don't know if
Yeah, it's a good question. Actually, I don't know honestly the answer to that question, but happy to look.
But depending upon like if you are defining schemas or like you said PubSub, right? You can define schemas as it evolves. You will be able to translate that into the tables, but it's not applicable to any other source which is pushing. If you look at third parties, if you have like Informatica or like Strim or some sort of like even Fivetran who is writing, you probably will be able to provide the context to each and everything and adjust the schema as you evolve. But it would not be one solution. You will have to pick and choose each and every use cases you will be using to create those tables. And of course, like creating context, like when it's everything is about AI going forward, not just like columns would do. You have to give a context of what this column is, so that you will be future-proofing your your columns for machine learning or AI interface at a later point. So there is no one solution for that. Not from a BigQuery standpoint. You'll have to rely on the tools and utilities you would be using to persist that table into BigQuery.
Send us an email if you with me a question. My email ID is karmarkar@google.com. Just send us an email.
Yeah, sure.
Yeah,
sure.
yeah. Then we can chat more.